Right. Assalamualaikum. Good afternoon, everyone. I think we can start. Right. So, yeah, back to this course, biostatistics. Previously we have covered LU2. We're still in LU2. So let's just have a look at what we have covered in LU2. The first test, LU2 is about non-parametric tests. So non-parametric tests are statistical tests that are used to analyze non-parametric data. So what are types of non-parametric data? Data that are ordinal, data that are nominal, and data that we do not have enough information about the distribution. Okay? So when we don't have enough information, we cannot assume the distribution. Distribution is like the pattern of the whole data. And then another characteristics of non-parametric data is when the number of data is small. So what is meant by small data, small n, when the n is less than 25. Okay, so that are among the characteristics of non-parametric data. So for that, we have to use non-parametric tests. So the first test that we have covered was Sine Test. So it was the simplest non-parametric test. So it just considers the sign. Yeah, we don't consider the magnitude or the values, the difference. So again, in statistics, we are always concerned with comparison because we want to know how the data varies, how the data, what's the difference between the data in terms of the means, whether it is significant or not significant. So that's why we are making comparisons a lot. And we are talking about means of the sample because the means represent the whole data of a sample. Yeah. And when we analyze a sample, actually we want to find a picture about the population because sample is one of the subsets. It's a subset of population, isn't it? So whenever we collect the samples, for example, you just imagine Unimas, we collect the samples from Unimas. So it means that our sample, the student samples consisting of data from the students. It can be students from Faculty of Science, Faculty of Economy, Faculty of Engineering, Faculty of Social Science, art, creative arts. So it's like it's from everywhere, isn't it? And we want to actually find a picture about that sample where we want to view it to represent population. Okay, so that's the relationship between sample and population. So that is the concern in statistics. So whenever we are analyzing the samples, yeah. So 2 samples, 3 samples. So you imagine that sample actually represents its population. Okay. All right. So Sine Test was the first test that we discussed under LU2. The second test was Wilkinson Sine Rank Test. So this one is more sensitive than Sine Test because we consider the difference, the magnitudes or the values of the difference. Okay. All right. So today we are going to proceed with another non-parametric test called Mann-Whitney test. Okay? So every test it has its own name, which where the name is the name of the, I suppose is the name of the statistician who invented the test. Okay, so that's why it is named so, Mann-Whitney test. All right. So what's the difference between the first 2 tests that we have discussed and the test that we're going to discuss today? So previously, Sine Test and Wilkinson Sine Rank Test, all of these tests are for non-parametric data, but the difference is in terms of the data. So Sine Test and Wilkinson Sine Rank Tests are used to analyze dependent samples. So what is meant by dependent samples? Samples that are dependent, like it has to be connected to each other. Okay, right. So whereas today's test, Mann-Whitney test, is a test which is designed to analyze two independent samples or two independent sets of data. Yeah. So that's the biggest difference between Mann-Whitney test and Sine test and Wilcoxon Sine test. So let's have a look at it directly. It's going to be a short lecture, I suppose. It's not that much, yeah. Right, I hope that I can finish within an hour. Okay, the test is called Mann-Whitney rank sum test. Okay, so I've mentioned just now it is used for analyzing two small independent random samples. So this is the key words for this test. Okay, independent, two small independent random samples, which are taken from identical populations. So here, one sample is taken from population 1. Okay, another sample is taken from population 2, but we assume that the two populations are identical. So that is the definition. Okay. It is also this test is also called U test. Okay, U test because in the test later you'll see that there is a parameter called U that we are going to calculate. All right. So Mann-Whitney rank sum test does not assume that the two populations have normal distribution. Okay, this is, I think, this is equal to any non-parametric data. We assume that we do not know about the distribution, the pattern, and also we assume that it doesn't have the normal distribution. Normal means like this. Normal means it's like this. Yeah. So which is synonymous to data sample which has large number of data. For example, if the n is 50, more than 25, more than 25, so you will see that the distribution of the data will tend to be normal. So this is based on observations by the statisticians. They have seen many examples of it, and they have concluded that normally if parametric data with a large number of data, it will tend to have distribution of normal distribution or bell curve distribution. Okay, so this is what we call normal distribution. Two independent samples are taken from the same kind of population with, okay. All right, so that's some introduction. Okay, so imagine that we have two samples from two populations. Right, so we are going to compare that two samples. Right, so that's the objective of this test. And how we're going to construct the hypothesis. So similar to other tests, the first step of this test is to set the hypothesis. So the hypothesis can be divided into null and alternative, right? So we have to set it. So now, based on our situation now, we have two samples. So it means that, let's say we have sample 1 and sample 2. So the mean of sample 1 is denoted as this symbol is mean, yeah, mu, which means mean, okay? And this one is mu 2. So since we are comparing the two means, so the way how we write the null hypothesis, it should be, in words, you can say there is no difference between mean of sample 1 and mean of sample 2. So if let's say the problem indicates specifically what sample 1 is, what sample 2 is, for example, like school A, school B, or maybe team 1 or team 2. So you have to mention it specifically, right? So the null hypothesis should say mu 1 is equal to mu 2, or there is no difference, there is no change, or there is no difference. Okay, so you can express in this way, or you can express in words. Whereas the alternative hypothesis is always the opposite. So the default way is always this way. Yeah, because it's the opposite of this, right? But if let's say there are some information stated in the question, let's say you want to say that test the hypothesis that the mean of team 2 is more than team 1. So that sort of information I define as extra information. Means that you have to follow that particular situation. So you can, yeah, you can, because this one is actually when it is not equal, it could be two conditions. Mu1 could be greater than mu2, or mu1 could be less than mu2. So this condition is only stated if there are extra information. Okay, if there is no extra information, if let's say the question sounds like test the hypothesis that there is a significant change between the mean of the two samples. Okay, so significant change, it sounds that you don't know which one is greater, which one is less. So in that case, you have to use this one. Okay, so the construction of the alternative hypothesis is very important because that will determine the parameter of U that you will calculate and decide later. Okay, we'll go through the steps of this. So it's similar to Wilkinson Sine rank test as well. So the alternative hypothesis will determine your value of the things that you want to compare during the steps. So I forwarded you this step, this procedure in your in the Telegram channel. So if you refer to your mobile and you're having your laptop, you can have a look at it. This outline, so that is much easier. Okay, so the procedure for the Mann Whitney rank sum test. So here are some procedure. There are 9 procedures, 9 steps. So, but as I said before, the first and the last step is always a similar step to other tests, which are the hypothesis for the first one, and the last one is the conclusion, or even the second last one is to make a conclusion. Okay, so that is typical to any other test, right? So that's the thing that you have to know. So means that yeah, so you have to start with the with the hypothesis, null and alternative hypothesis, and then the second step is to combine the two samples. So what is meant by combining the two samples here is for ranking purposes. Okay, for ranking purposes. It means that you have to see the whole data, the two samples as the whole data. Okay, I'll show an example after this. And then the third step is to rank the combined sample using type ranks if necessary. So if it is not needed, then you don't have to find type ranks. But if it is necessary, you have to find the type ranks. So I hope you still remember what is type ranks. Okay, so the fourth step is to calculate the sum of ranks of sample 1 and the sum of ranks of sample 2. So remember, even though the second step asks you to combine the samples, but you still have to remember that they are of two different samples. They are of two samples. Okay, so you have to differentiate which data letter belongs to sample 1, which belongs to sample 2, and what's the sum of ranks of each sample, right? Now, the fifth step is to find what is U1, U2. Okay, so this is the specific parameter for this test. Okay? So it's also called U test. So the parameter that you calculate is, one of them is U. Okay, why U? I do not know why, because it has been decided by the statistician before. Okay, I don't have the answer why it is U and not I, maybe. Okay, so you have to calculate U1, which refers to the sample 1, and U2, which refers to sample 2. So the formula is U1 is equal to S1 minus N1 in bracket multiply with N1 plus 1 divided by 2. Okay, so be careful with this expression. It's you have to settle it first before you subtract from S1. Okay, same goes to this one. Yeah, the pattern is the same, but it's just that you replace N2, N2 in the expression, and N1 and N2 here refers to the N of the sample. Okay, the number of the data of sample 1 and sample 2. Right, the sixth step is to determine the test statistics U. Okay, so just now you label here U1, U2. It's not U. It's not U on. It's not U. So be careful with that, because in the sixth step you have to calculate the U alone. Okay. So in the sixth step you have to determine U based on these conditions. So that's why I said just now the alternative hypothesis, it plays an important role in determining the U value. Because if, let's say, you assign wrongly, you'll get different U values. Because if, let's say, you set the alternative hypothesis as this one, okay, not equal, so means that the U will be equal to the minimum value between U1 and U2. Okay, last time I introduced you this function, right? Minimum. Minimum means what's the minimum value between the U1 and U2 value that you calculated in step 5. So means if, let's say, the example is 3 and 5. Let's say U1 is 3, U2 is 5. The minimum of 3 and 5, between 3 and 5 is 3, isn't it? Because that's the lowest value. Okay, so that's what it means. Okay, so this is for this condition. But if, let's say, it is one-sided, yeah, for example, U1 is less than U2, so you have to assign U equal to U1, okay, and for U2, if, let's say, the other way around, yeah, this one is less. So if U1 is greater than U2, then you have to decide U as U2. Okay, so that's the different conditions for U depending on the alternative hypothesis that you have set. Okay, that's sixth step. Seventh step is to determine critical value, or CV, from Mann-Whitney U test table. Okay, so this test also has its own standard table called Mann-Whitney table. Okay, so how the Mann-Whitney table looks like. So there are 4 conditions actually. I have uploaded the file, the table file, on Elite. So this one is not, it's actually the same thing, but here is it has been merged, so it might not be that really clear. So later you can see the file itself. Okay, so there are 4 conditions that you have to consider. What's the difference between all of this is the alpha value. Yeah, later you see, if you see clearly, it's the alpha value. Alpha value, and also is okay. There are 2 conditions: one-sided, and is whether it's two-sided or one-sided, and what's the alpha value. So if, let's say, you have already, like, your test is one-sided, and then it is indicated in the problem that the alpha that you have to refer is 0.05. So you have to find that 2 conditions around this table. Okay, for example, one-sided, alpha 0.05. So it falls under this condition. So you have to use this table. Okay, but if, let's say, it's two-sided test with alpha 0.01, so it falls under this, then you have to use this table. Okay, so it depends on the conditions. So how to know that conditions? It depends on the nature of the questions that you are analyzing. Okay, so just want to highlight here that there are two information that you have to look for, whether it's one-sided or two-sided, and also the alpha value. Okay, all right. So the CV, the critical value is this one. This is what you are looking for. It's either one lah, mana table that is that suits your condition, but this value are CV. Okay. So another thing that you have to know when you use this table is N1 and N2, because that will determine your column and your rows over here. Okay. Right. So that's how you find the CV, the critical value from Mann Whitney test table. Okay. So that is the 7th step. Determine the critical value from the table. The 8th step is to make a decision. So based on what condition? Based on this condition. Okay, this is the condition. Means this one means that you have to compare the U from the 6th step with the CV from the 7th step. And then you compare which one is bigger. So if let's say U is less or equal to CV, then the decision is to reject the null hypothesis. Okay, so that is decision number 8. Okay, number 9 is to make a conclusion. So decision is not yet complete. If let's say you just say, you just end up your workout until here, you just say that accept null hypothesis, and that's the end of your workout. It's not completed yet, because we do not know what do you mean by null hypothesis. If let's say you read a report in the newspaper, so the result is to accept the null hypothesis. It doesn't state like, okay, there is no difference between the number of vaccinated people in maybe in Sarawak and in Johor. The percentage is there's no difference. So that's clear, isn't it? But if let's say what happened if let's say the reporter just say that the null hypothesis is accepted. So who understand your null hypothesis? So that's why you have to define impact. So that's the rationale of stating the conclusion clearly, because when you analyze the data, it is only you who understand the data, but not the audience. But the most important thing is you want to communicate to your audience what's the conclusion, isn't it? So that's why we emphasize this step, whereby you have to make a conclusion. You have to state back the hypothesis that you decide to accept or reject in detail. In detail means that you refer back to your problem. If let's say your problem refers to two themes that you want to compare, so you reject the null, means that you accept alternative, isn't it? Alternative hypothesis means there is a difference between the mean of theme A and theme B. So that is more meaningful. So your audience would understand what you are trying to say, isn't it? Rather than if you just saying that you accept the null hypothesis or you reject the null hypothesis. Okay, so that's why you have to state clearly that conclusion. Okay, so that's are all the steps, and this is the tables of Mann Whitney. And that is actually, that's all for today's lecture. That's what the test is all about. Okay, now let's have a look at this example. I'm a bit tired because I have a lecture this morning, and it's fasting month. Okay, let's have a look at this example. The bacteria counts per unit volume are obtained for two types of culture, A and B. It is of interest to determine whether one culture has a significant count than the other. Use 5% level of significance. Okay, so given to you this problem, so the question is actually up to here. So this is the question. So this one is already the solution. Okay, so what is given in the question? So you can see that there are two samples, two set of data, obviously. And if you see the number of the data, the n is only 4, isn't it? N is only 4 for both data. So it is considered small data, small number of data. So, and it's less than 25. So means that from there, even though it is not stated directly that this is non-parametric data, you have to know by yourself that, okay, the n is small, and obviously this falls under the category of non-parametric data. So how you want to know, I mean, what will give you some more hints? You have to analyze the types of data. Here, the vector counts per unit volume are obtained for two types of culture. It is of interest to determine whether one culture has significant count than the other. Okay, so you can see the nature of the data here. They are not actually related. There are no keywords like repeated measurement, before and after, or it's not stated that the dependency of the data. Okay, so that's how you know that the data are independent. That's another thing that you have to know by yourself. Yeah? Independent data. Okay, so n is less than 25, and this is independent data, and it involves two samples. So from there, you know that you have to use Mann, Whitney test or U test. Okay, so another information from this question is 5% level of significance. So alpha is 0.05, right? Is given, so you just have to use the value given. Another key information is this one. It is of interest to determine whether one culture has a significant count than the other. So significant count than the other, it doesn't mention higher or lower. So it's just that a difference actually, yeah? Whether there is a significant difference or not. So why this one is important? Because this will help you to construct your alternative hypothesis. Remember, you have to set the hypothesis, right? Right. So yeah, now let's have a look at the solution. Yeah. So the first step is to set the hypothesis. So obviously this one you have to label correctly based on the data, based on the problem, because the problem says here it's, yeah, you can also put A and B lah, B and B, X, Y, because this one defined directly there. Okay, instead of saying X and Y, you can also put A or B, okay, based on the problem. And then, because of this statement, significant count than the other, so you can use this symbol, or it is actually two-sided test. So not equal to. Yeah? Okay, so that's the hypothesis. And then the second step is to combine the data, isn't it? So if you refer, I don't want to go back to the steps just now, otherwise it will make you pening tengok tu. So if you refer to your mobile, the steps, I've given the test, the outline of the steps. So the second step is to combine the two samples. So to combine here is for the ranking purposes. So ranking, remember ranking? Ranking means we give a rank of the data from the lowest to the highest. Okay, so these are the data, right? 25, 26, one, yeah? So the lowest, when we combine the data, means that we see the whole the two samples are as one big sample, okay, and we start ranking. So the lowest one is 25. So we rank it as number 1, number 2, number 3. Number 4, this one, right? So it belongs to sample B. Number 5, number 6, 7, and 8. Okay, so here we don't have type ranks because there are no two similar values. So we don't have to find type ranks. So we just rank it normally, like this one, from 1, 2, 3. This is a whole number, we call it whole number. Okay, so it's actually much easier rather than if you have to find type ranks. Now, that is step number 2, or step number 3 already. Rank the combined sample. Step number 4, calculate the sum of ranks. Okay, now remember that these are still 2 different samples. Yeah, so you have to know that this is sample A, right? This is sample B. So you have to sum the ranks, not the data. This is data. This is data. This is rank. So you have to sum the ranks. So means that you have to plus 1 for the sample A. Okay, so these are the ranks, right? So 1, 2, 3, and 6. Okay, that's equal to 12. And for sample B, or sample 2, it's this one, 4, 5, 7, and 8, because this belongs to this. This is sample B, isn't it? So you have to add up all of this, 4, 5, 7, 8, give you 24. And the n is similar for both, which is 4, right? How many data are in the sample? Okay, so we have that information. Then means that we have we can calculate number 5. Step number 5 is to calculate U1 and U2. Okay, now U1 and U2, remember the formula for U1 is equal to S1 minus N1 plus 1 divided by 2. U2 is the same, it's just that the symbol is different. And 2 and 2 plus 1 and 2. So that's the formula. So you apply it, substitute the values. S1 is 12, right? And S2 is 24. So we got 12, 24 here. And then N is 4. 4 plus 1 is 5. So that's why you got this. 4 outside. You solve this one first, before you subtract from 12. So 5 times 4, 20. 20 divided by 2 is 10. 12 minus 10 is 2. That's how you got this. And same goes to this. So now you got U1. Okay, remember this is U1 and U2, not U yet. So next one is you have to determine U. Okay, so how to know this? You have to refer to your to the steps, the 6th step. You can see that there are 3 different conditions, right? So this one falls under the first condition. So means the U is equal to the minimum U and U1, U1 and U2. So means the minimum of 2 and 14. Which one is the lowest value? Is 2, isn't it? So that's why you got 2 here. So now you got U equal to 2. Okay. Right. The next step, the 7th step, you have to find the critical value from the Mann-Whitney test table. Okay, so what's your condition? First, you have to identify your condition first. So you have N1 equal to 4, N2 equal to 4. Your alpha is equal to 0.05. And this one is the two-sided because of your alternative hypothesis is this one. So this one means two-sided test. Okay, so if it is 1 or greater or less, that one is one-sided. Okay, so why this information are important? Right, this one two-sided, because we want to refer to the table just now. So now let's have a look at the table. So these are the tables. So means that you have to find the information that matches your condition, or the table that matches your condition. So now you have two-sided alpha 0.05. Okay, this one is not. This one is 0 alpha. Is it this one? Two-sided alpha 0.05. So that's the condition, isn't it? Okay, so you have to use B, table B. And then your N1 and N2 is 4. So N1 is 4. This is N1. And slightly larger. Okay, that's better. N2, this is N2 is 4. So this is the CV value that you are looking for, which is actually 0. Okay, so take that value, go back to your steps to start. So now your CV is equal to 0. And you want to compare with your U value, which is 2 just now, right? So, if you have a look at the steps just now, you reject null hypothesis if U is less than CV. So now U is 2, CV is 0, is greater than CV. So means that is the other way around. You have to accept the null hypothesis, right? So accept the null hypothesis. That's your decision. That's on this condition, right? So the conclusion is that what is your null hypothesis? Back to your problem. There is no difference. Okay, of course you have to add this sentence. At 5% level of significance. This is important because your analysis is based on that alpha value. Okay, so this one is compulsory to be stated. At alpha equal at 5% level of significance, or you can say at alpha equal to 0.05, there is no difference, or you don't want to use this one. There is no difference in the means of sample A and B. Okay, so that is the conclusion. So it's quite easy, isn't it? So you just have to familiarize yourself with the steps in the middle, where you have to combine the data, rank the data, and then find the sum of ranks, S1, S2, find the N1, N2, okay? And then you have to calculate the U1, U2, determine the U, right? Based on your alternative conditions, alternative hypothesis condition, and then compare the U and CV, make a decision, okay, based on the rule of thumb given in the steps, and finally make a conclusion. Okay, so that's it. So means here there is no difference in the means of sample A and B. So means this is no difference, is actually similar. It is the same. The other words you can say sample A and B are similar. We don't want to say no difference. Okay, so that's example 1. Example 2, you can go through by yourself. It's the same thing where you have to apply the same steps. Okay, so but now you can see that the data are a bit bigger, more than 4. 1, 2, 3, 4, 5, 6, 7, 8. So this example, what I would like to highlight is that, okay, so you are given this data, this question, and you can see that the number of sample is not the same for method A and method B. So this one you see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. This is 11, and this one is 12. So this is one example that the data are independent. That is the unequal number of the data is one characteristics of independent data. Means that, you know, you don't have to match which one by which one. So independent data, they can be of equal size of sample, and they can be also unequal like this. Okay, so that's why we give you this example. And how to solve it is the same. It's the same, like, yeah, you apply the same steps. All right. So I have another practice problem. Okay, the thing is, some of you asked me the answer for the questions that I've posted on eLib, isn't it? So actually I got it from internet, and I also do not have the answer for those questions, because I just want to help you to practice. But what you can do, you can discuss with your friends. You know, like you follow the steps given in the lecture notes, right? So if 3 of you, 4 of you are following the same steps and you got the same answer, so that's how you discuss with each other. Okay, you can discuss with your subgroup members or any friends, anyone from other groups. So that's how you study at the university level. Okay, so that's the difference actually between the university level and the school level, the matriculation level. So the lecturers are just to guide you, but we cannot provide every single thing. Okay, it's not because we do not want, but we want to train you to be independent, and we want to train you to be in a discussion environment. Okay, after this, you're going to discuss a lot with your friends, and you have to develop that kind of skill, that kind of techniques of discussing. Okay, and that's how you get to know each other as well, right? So that's the thing. Or maybe you can ask me, if let's say you maybe 3 of you have answered the questions. You have, I mean, if let's say it's you can show me the workout, okay? Maybe I can verify, okay, that's correct. Or if let's say you have some disagreement about the answer, yeah, maybe you can come and you can email me, okay? But provided that you have discussed with your fellow classmates or friends, okay? All right, I think that's it for today. Yeah, as promised, I don't want to take that very long, and this topic is quite short. So yeah, for the mid-semester exam, don't worry, it's not going to be on what, on apa itu? 26 the time is not relevant as well. So it is now proposed to after Raya. Let me see the date. I will post on eLib, but I just got the date from the coordinator. It's going to be on the 14 May. 14 May, Saturday morning. Okay, so we don't have a choice to make it on weekends, because I think some of the classes do not have the same time, so we cannot do it on during the class time. That's one thing. And then we do not want to do it at night, because it might not be convenient for some of you who are not staying at home. Okay, so we have to sacrifice weekends. We can Saturday morning. Okay, so that's the limitation now of the things that we have to compromise for the exam. So the mid-semester exam will cover LU1 and LU2. So for this LU2, we're not done yet. We're going to have 2 more tests. After this, we have Kruskal-Wallis test and also Friedman test. So after that, you can finish your tutorial 2, and I will give feedback on tutorial 2. Okay. So tutorial 2, for the tutorials, I will give feedbacks, because that one are graded. So for the homework, for additional practices that you want to do, you want to exercise, you want to have some practice, that one you can have a discussion between your friends. Yeah, I think that's it. Okay, I will post the information about the mid-sem exam. So it's going to be next month. Yeah, okay. So we have ample of time to do revision. And also for the tutorial 2, okay, if let's say you feel that it's a bit tight for you to submit the tutorial 2 on the berapa, because last time I put the date based on the initial date of the mid-sem, so that's why I want to make it before 26 April. So we can shift it to maybe end of April, okay, maybe before the Raya, so that you finish your tutorial before Raya. Then I can give feedback after Raya, and it's just nice before the mid-sem exam. Okay, maybe I put it 30th April for tutorial 2 submission. And you just assign one of the representative to submit on ELIP. Okay, don't submit multiple copies. And how you do the tutorials, every one of you in the group, even though there are 5 questions, maybe you can divide the questions, but I don't think so is an ideal way. You have to attempt all the questions by yourself first. And once you get your workout, your answer, you discuss with your team members. So that's how it works, okay? And if you have like differences in your answer, then you can discuss on why it's different, why your method is different. What's the problem, or what's the errors maybe? Okay, so that's how it works. Okay, so I'll show back the attendance. If there is no question from you, we can disperse early. Okay, guys? All right, okay. Okay, those who have scanned, you can leave. Huh? Alright, selamat buka nanti. For those who are fasting. I dah penat kan, lemak suara dah sedap dah. Okay, thank you very much for your attention. All right.
Thank you, Doctor.
You're welcome.
Thank you, Doctor.
You're welcome.